Assalamu alaikum and very good morning. Today's topic is nucleophilic substitution reactions. What are nucleophilic substitution reactions? Explain SN2 and SN1 reactions with the help of examples, or explain SN2 and SN1 in tabular forms. So let me to first define what are nucleophilic substitution reactions. So the reactions in which one nucleophile replaces another nucleophile from a compound is called nucleophilic substitution reaction or SN reaction. For example, Nu, it is nucleophile because nucleophile means nucleus loving. So it will carry negative charge. So of course it will attract positive. So it will attack on R, which is partial positively charged, and X, which is partial negatively charged. So Nu will attach with R, and X will be eliminated from the compound. So it forms NuR. So Nu has replaced X minus. If you take a typical example like CH3 CH2 Br plus OH, it comes from a base which is nucleophile, and it is negatively charged, so it will attract positive charges. So it is nucleophile because it is nucleus loving. So this OH will leave Br from this compound and will form CH3 CH2 OH plus Br minus. Now comes towards the mechanism. The mechanism of nucleophilic substitution reactions. There are two types of mechanism for nucleophilic substitution reactions. One, nucleophilic substitution bimolecular, which is called SN2. Number two, nucleophilic substitution unimolecular, which is called SN1. So let me to explain first SN2. Nucleophilic substitution bimolecular reaction or SN2 reactions. So these have the following steps. And SN reactions, SN stands for nucleophilic substitution reactions, in which breaking and formation of bond takes place simultaneously. Simultaneously means at a time, is called SN2 reaction. It is a single step reaction because it completes in one step. In other words, the extent of bond formation is equal to the extent of bond breakage. Means when bond is formed, so at the same time old bond will be broken down and new bonds will be formed. Here take example, this is nucleophile, it attacks on this carbon, right? So it forms what? HOCH3. So the molecule is inverted. So NSN2, this is the substrate. Nucleophile attacks on this one. This is probably alkyl halide. So this is called substrate. And this is the slow step, and this reaction completes in a single step. So this slow step is the rate determining step. So here two molecules are involved. One is OH and the other one is CH3Br. So the order of action and molecularity will be 2. And SN2 reaction, the direction of partaking nucleophile is opposite to that of leaving group. This is the leaving group because it attacks on the opposite side because both are negatively charged. So this nucleophile cannot attack at the front. So it will always attack at the opposite sides of the leaving group. In SN2 reaction, the configuration of alkyl halide is 100% inverted. Means the molecule becomes inverted. Next step, number 4, in SN2 reaction, there is only a slow step. Means there is only single step, and that is slow step. So it is called rate determining step. Because two molecules take part in slow steps, so it is called bimolecular reaction. Because two molecules are involved, one is nucleophile, the other is probably alkyl halides. So it is called bimolecular reaction. It is the reason that mechanism is known as SN2. The rate of SN2 reaction depends both on the concentration of alkyl halide and attacking nucleophile. So rate is equal to K is rate constant on the concentration of alkyl halide and concentration of nucleophile. Point number 6, in SN2 reactions, the molecularity in order of reaction is 2. Point number 7, in SN2 reactions, carbocations means C plus carbonium ion is not formed in this one. Point number 8, primary alkyl halide shows SN2 reactions. Point number 9, secondary alkyl halide shows SN2 reactions in nonpolar solvent. Now comes towards SN1 reactions. SN1 stands for nucleophilic substitution unimolecular reaction. The SN1 reactions in which breaking in formation of bonds do not take place simultaneously. Do not take place simultaneously means at a time. It is completed in 2 steps. So it is 2 steps reaction. In other words, the extent of bond formation is not equal to the extent of bond breakage. So here, this is tertiary alkyl halide. It ionizes in water and it forms carbonium ion. This is carbonium ion. Then OH is attacked on carbonium ion on either side, from this side or from this side, and form tertiary alcohol. In SN2 reactions, the attacking nucleophile can attack from both sides easily. So it is 50% inverted configuration and has 50% retention configuration. Point number 3, in SN1 reactions, the configuration of alkyl halide is 50% inverted. Point number 4, in SN1 reaction, first step is slow step and reversible, and the second step is fast because only one molecule takes part in slow step, so it is called unimolecular reaction, and it is the reason that mechanism is known as SN1. Point number 5, rate of SN1 reaction depends upon the concentration of alkyl halide only, right? So R rate is equal to K. K is rate constant. Concentration, this sign stands for concentration of alkyl halide. Number 6, in SN1 reaction, the molecularity in order of reaction is 1 because only one molecule takes part in the slow step, and that is the rate determining step. So the order of reaction will be 1 because we can define as the order of reaction, yani the means reactants participating or involved in the rate determining step will be the order of reaction. So here the rate determining step, only alkyl halide is involved. So the order of reaction is 1 and the molecularity is also 1. And SN1 reaction, the carbonium ion is essentially formed. So here carbonium ions will form must. Number 8, a tertiary alkyl halide shows SN1 reactions. Number 9, a secondary alkyl halide shows SN1 reaction in polar solvents. So this was about nucleophilic substitution reactions of alkyl halide. So there are 3 types of alkyl halides: primary alkyl halides, secondary alkyl halides, and tertiary alkyl halides. So next topic I will upload, and before that please subscribe my channel that you receive the recent videos regarding alkyl halide. And thanks for watching my YouTube channel Chemistry with GS. Allah Hafiz.